for our third speaker. As you can see there, the title is A Sequence-to-Sequence Transformer Data Logic Experiment. Over to you.
Good afternoon, everyone. So this project of our team talks about a sequence-to-sequence transformer data logic experiment. Next page. Today, NLG technology is widely applied to automatic writing of article reports, which effectively reduces manual work. In the financial landscape, however, text generation can be very demanding as to the level of constraint a non-descriptive model should comply with. The object of our work is to explore a data logic that as if they were written by a real human person, and evaluate the validity of RDF form data on T5 model. Okay, sorry, there's a problem with it. Okay. The reason why we choose RDF form data is because it can particularize the key information inside the sentence so that it eliminates interference caused by irrelevant information and its predicates hint at the relation between the subject and the object. Therefore, sentences of certain intention, that is to say, of certain semantic meanings, are extracted and transformed into RDF form data to constitute our data set. Here is an example of the here is an example of a sentence of intention describe value and its RDF form data. The revenue and $9 billion in 2019 are key elements in this sentence, and they are connected by predicates such as val is, which means value is, and d time, which means dimension time, to form a set of triples, which are referred, and this whole triples are referred to as triples hereinafter. And next, we will went through the project step by step. First of all, we collected a set of public online market reports as our initial corpus, and 4,159 raw corpus files were prepared for the next step. Next, we built a sentence annotator to extract a sentence from financial reports written by a real person and annotate the factual information inside sentence. These sentences will be used to evaluate the generated sentence, since we expect that our data logic allows us to generate human written-like sentence for financial report. Then, a triple constructor extracted factual information, or we can name them as key elements with predicates to form a triple, and two triples are linked by an ampersand to constitute triples. Next, we fine-tuned the T5 model with extracted sentence and their corresponding triples. During this process, triples serves as the input and sentences as the label. It is notable that we didn't put too much work on fine-tuning the T5 model, since our object is to evaluate the formalism of our data. Next, we search for the most suitable beam search parameter for the generation, and before the final evaluation, we created reconstituted triples based on generated sentence, so that we can compare reconstituted triples based on generated sentence, so that we can compare reconstituted triples with initial triples. And for evaluation, we adopted BERT score, blur, triple blur, and triple BERT as the metrics. BERT score and blur are used for evaluating the semantic similarities and the lexical similarity between sentences respectively. However, they are incapable of evaluating the completeness of generated sentences. That is to say, whether the generated sentences contain exactly the same factual information as the original sentence. To achieve this, we evaluated the lexical similarity between initial triples built from initial sentences and the sentence built from generated sentence with triple blur and triple BERT. Then we talk about the data construction process, which contains two steps: sentence annotation and triple construction. The three most important elements for sentence annotator are key element, key component, and intention. For most cases, key elements refer to the factual information in a sentence. For instance, the financial indicator, measures, reference, causal connector, and predicates. The key component is composed of key elements, and it is defined by the type and number of key elements in it. We have 7 categories and 11 subcategories of subcomponents. Then, by the type and the number of key components in a sentence, we define the intention of a sentence. Here is an example for better comprehension of the annotation process. When a sentence annotator receives a sentence, for example, in China, the revenue increased by 10% in 2020. It at first annotates the key elements inside. We have in China as the location, the revenue as the financial indicator increased by the predicate, 10% the matter, and in 2020 time. And we have defined in the grammar of sentence annotator that an indicator plus a predicate whose type is described object increase plus a matter and plus a time is a key component named as predicate variation. Since there is only one predicate variation in this sentence, the intention of this sentence is described variation. And then the key components. Key components can be divided into 3 categories. Those in the first category are used for describing the value or state of one or more than one indicators. The difference between predicate value and expression value is that in predicate value, there is verbs. However, in expression value, there will be no verbs. For example, for predicate value, we have the revenue was 10 million, and for expression value, that will be revenue of 10 million. And what makes predicate entity special is that its subject is an entity, for example, company, instead of an indicator. And the key components in the second category are used for describing a variation, and the logic is the same as the first category. And for expression contributor, it is used for describing the relation between 2 parts of a sentence. According to the relation type, they can be further divided into cause-effect contributor, relevancy contributor, and contribution contributor. Last but not least, the intention. According to the semantic meaning of sentences, they can be classified into different intentions. The 2 basic intentions are described value and described variation. When a sentence contains more than one described value, the intention of the sentence will be merged described value. And when there is an described value plus a expression contributor, the intention of the sentence will be described value with contributor. And when there is more than one described value and also expression contributor, the intention will be merged described value with contributor. And the logic is the same for the intentions based on described variation. Now we talk about the triple construction. Our triple contributor receives a sentence and annotates it with the help of sentence annotator, then extract the key elements inside and connect them with predefined predicates to create triples. Since we have noticed that T5 model can only process triples with limited length, that is to say, when triples are too long or too complex, the model cannot generate a sentence complete or correct. To prove the validity of our data logic, we created a simple triple by adding a function that simplifies the input sentence, and based on simplified sentences, the triple constructor will generate simple triples. This method cuts the average length of triples by half. Here is a concrete example of complete triples and simple triples. As we can see, the key elements in the first sentence are replaced with simpler elements, and this is simple triples. Two elements are connected by a predicate to form a triple. At last, from 4,159 raw corpus files, we paired 20,620 annotated sentences with their corresponding triples. The frequency of every intention is shown in the table below. So we have the dataset of simple triples and also of complete triples. For experiments, we compare the original sentence with generated sentences, and also original triples with generated triples. And we added triples in the evaluation for sentence in financial report are expected to contain all key because the sentences in financial report are expected to contain all key information provided in the input sentence. However, blur and burst score are incapable of examining the completeness of generated sentence. To achieve this, triples are added to the evaluation. And there are three types of data. First of all, complete sentence and its corresponding complete triples. And to verify the validity of our data logic, we added simplified sentences and simple triples. To affect the metric to sentence generated at inference from simple triples models, we retained two features: the restored generated sentence and its corresponding triples. Restored reconstituted triples. Here is an example of restored generated sentence. As we can see in this sentence, we restore the simplified elements in the simplified sentence by the original elements in the original complete sentence to create a restored generated sentence. We have conducted two experiments. One was on T5 model fine-tuned with complete triples, and the other on model fine-tuned with simple triples. For each experiment, we compare the generated sentence with the initial sentence and the initial triples with the reconstituted triples. Here are results for the experiment, taking sentence BERT as the metric. There is a little difference between the aggregated measure for sentence generated at inference from complete triples, simple triples, or restored triples. And taking a blur sentence as the metric, which evaluates the sentence on lexical level, as we can see in this chart, as the complexity of intention increases, average blur score for simplified sentences generated from simple triples exceed blur for complete sentence and restore sentence. And the average sentence blur for simple triples is the most steady one. This proves that the simplification of initial sentence and initial triples does improve the performance, while the result for restored sentence is not as satisfied as that of simple triples. This may be caused by the risk of information loss during the process of restoring the sentence from the simplified generated sentence. And from triple blur, it is easy to see that simple triples gives a much better performance than the other two types of triples, which proves the validity of our data logic. However, no matter for simple triples or for complete triples, there are regenerated sentences from which reconstituted triples cannot be generated, as shown in the column non-triples. But the number of non-triples for complete triples outnumbers that of simple triples. This is another proof to the validity of our data logic. Hence, we can conclude that simplification of sentence helps on improving the performance of T5 model and evaluate the similarity between the original triples and the reconstituted triples is more suitable for evaluating the quality of generated sentence in financial landscape. An RDF to text method is feasible for financial sentence generation, but further improvement is required. For further work, we will continue to improve the sentence annotator by expanding dictionaries for key elements and completing and increasing the template coverage for more sentence structure, especially for complex intention, and leverage the induced bias of the triple generator as to propose more accurate automation of the triple extraction, and work on the current limitation of T5 model to extend the length of input sentence sequences, keep memory construction as possible, and experiment with more advanced model. That will be the end of the presentation, and thank you all for your attention.
Okay, thank you very much, Daxin. So any questions, people, please either put them in the chat or you can unmute and ask directly. So I was going to start off, if there are no other questions right now, with kind of a question about the tokenization issues and whether that makes much of a difference. I mean, I could imagine hyphenation being different in some of the sentences in what you're comparing. Does the blue score or other evaluation metrics take that into account? You know, if you've got a partial match rather than a full match, is that taken into account?
I'm sorry, the internet is a little bit disconnected. Can you repeat the question?
I was wondering about the tokenization issues in the kind of boundaries of the elements that are going into your triples. So, for example, you might have something that's differently hyphenated, or maybe you have a partial match rather than a full match. Is that accounted for by the evaluation metrics that you are using?
No, unfortunately, for now, no.
Okay. Is that something that you've spotted, like qualitatively, is going to be much of a problem, or you think it's probably not really an issue for this type of data?
I think we should count it, but for now, as we can see, our evaluation is based on the generated sentences, which will be influenced by the quality of the initial triples. So by evaluating the quality of generated sentence, it sort of can reflect the quality of our initial triples.
Yeah, I mean, I don't know whether the generated sentences are more likely to be hyphenated or not, or whatever. So there might be still some difference there potentially. Yeah. Interesting. Okay. Thanks. Any other questions popping up? I don't know whether my Teams chat is frozen. Mo, can you just show yours on there? Yeah, no, I think we've got everything. Okay, thanks very much. And well done again from the local team.
Thank you.
Okay, thanks very much.